vertebral branch which goes to the brain. Now you should be able to talk about that one. A vertebral branch that goes to the brain. You know where it is, and you know how it gets to the brain. Another branch that comes off of this subclavian blood vessel is the thyrocervical trunk. The thyrocervical trunk gives rise to vessels that supply the thyroid, the trachea, and the larynx, and other structures. So that's a major vessel that you're finding. The internal thoracic was actually the first branch of your CAT that you located, the internal thoracic artery. We called it in the CAT the internal mammary. And there are some anatomy books that refer to it as the internal mammary artery. But most anatomy books call it the internal thoracic. It is an important blood vessel. And it is an interesting blood vessel. Something I pointed out to a couple of you. The internal thoracic artery, if you follow it up into the ventral body wall, some of you could see still on your CATs because it wasn't all cut off. This blood vessel continues in this parasternal region right here, along the edges of the thorax, all the way down the wall of the abdomen. You could follow it all the way down. And as it traverses this, follow me now, as this internal thoracic traverses this area close to the sternum, as it does so, sorry, that's the aorta. As this internal thoracic traverses this parasternal region here, it changes names. We call it then the superior epigastric artery as it enters the area of the abdomen. And if you continue to track it, just wait a few minutes, I'm going to give it to you. This guy is going to connect to the iliac system. I'm going to connect it to the external iliac artery, which gives rise to an inferior epigastric, which becomes the superior epigastric. So here's what I'm telling you. If you were to make your way, if you were, on your tiny little blood vessel spaceship, and you were inside the blood vessels, you could come out of the aortic arch, travel down through the thorax in this blood vessel, all the way down to the L4 at the bottom, take a turn and go into the external iliac artery. And then in the external iliac artery, you could make a superior turn into the epigastrics, into the inferior epigastric artery. And if you continued up that vessel, you could come up the superior epigastric artery into the internal thoracic and get back into the subclavian artery. Now, what does that sound like to you? Is this something you've heard of already? That is the largest loop. That's why the picture's here. This is the biggest loop in the body, the biggest anastomosing loop in the body. And what would happen? What would happen to the blood in this parasternal region if I were to cut a piece of the internal thoracic off? Now, I could cut a piece of it off and pull them together, or I could just suture the ends of the internal thoracic artery. I could cut a piece of the artery off and use it for something else. How is that possible? Wouldn't you rob the blood supply to this region? No, you would not. You could actually get blood to that region from the legs. And so cardiovascular surgeons use this internal thoracic artery. When there's a small graft to be made, a small bypass to be made, they will actually cut this artery out and use it during bypass surgery. Now, most of the time when you've got double, triple, quadruple bypasses, you need more vessel. So they don't use this one. They'll cut out a piece of the great saphenous vein, which I'll show you. But you can see the advantage here. I mean, the saphenous vein is a vein. The internal thoracic is an artery. If you're going to replace an artery, you should do it with an artery. So most people walking around with bypasses have veins attached to arteries. So this is it's a cool little vessel I always like to point it out. All right, the internal thoracic. And then this one you found also, the costocervical artery supplying blood all the way down to the cord meninges and the intercostal areas, the rib muscles, the costocervical. These are some of the major branches of the subclavian you found in the laboratory. All right. Now, as the blood gets to the axilla, the subclavians pass deep, you can see it passes deep here to the clavicle and become the axillary arteries. Now there are very specific ways to define the axillary and its branches, okay, which I'm not going to require of you. I want you to know the subclavians become axillaries, and then the axillaries then become brachial. Now, the last pieces of the axillary, the last portions of the axillary, have vessels that come off and supply the upper portions of the humerus. These you had to find also in the cat. These are the anterior and posterior humeral circumflex arteries. Can you see what they do around the proximal end of the humerus?
Circle it.
They circle it, forming an anastomosing system on the proximal end of the humerus. So the circumflex vessels form an anastomosing system here on the proximal side of the humerus. Then the blood vessel becomes the brachial artery, which you found. Now, the rest of these you were not required to find, with the exception of the radial and ulnar. But the brachial artery gives rise to the deep brachial, and look at what it does. The deep brachial artery passes posterior to the humerus. What muscle is it going to back there?
Bicep?
The triceps. Yeah, so the deep brachials come off. The brachial artery passes along mostly anterior and medial on the humerus. So if you had an injury, if you had a laceration injury in the upper extremity, where would you want that laceration to be? Medial or lateral? If you wanted to keep from hitting the major arterial system, right? Where would you want it to be? Lateral. Yeah. So the blood supply here is on the medial side of the brachium. And then it passes anterior at the cubital fossa. But notice what the deep brachial does here. The deep brachial artery then, if you follow this guy down, the deep brachial artery becomes the radial recurrent artery connecting to the radial artery. Notice that the brachial artery continues and becomes radial and ulnar. Now, what am I saying? What would happen if you had some weird impingement that occluded and blocked off the brachial connection to the radial and ulnar? Would the antebrachium be robbed of its blood? What is that? That is an anastomosing system. You see it? And it's not just on this side. Look at this side. So on the medial side, the ulnar recurrent artery comes off the brachial, and look at what it does. It connects to the ulnar artery. So if I were to have an injury to the brachial artery, you can see that there's not one, there's not two, there are three ways to get blood into the lower arm with these recurrent vessels that connect the brachial to the lower blood vessels, the radial and ulnar. A safety net of blood vessels through the elbow region to connect blood to the lower arm. Then you have radial and ulnar feeding these palmar arches. Now we're going to see these in the ankles also. The radial and ulnar run along the anterior sides of the bones for which they're named, and they supply arches in the wrist, a superficial and a deep arch. What do you mean an arch? Okay, well, let's look at a diagram here, and this will help explain it to you. Notice that I've got crisscrossing situations here. The deep and superficial palmar arches are supplying blood out to the fingers. So I would ask you this question. Is blood getting into my fingers by way of the radial or the ulnar or both? And if it's both, how so? The arches are both connected to both systems. So the system appears to create an anastomosis. Did y'all see it? An anastomosis here, an anastomosis here, and an anastomosis here. Isn't that interesting? Circumflex arteries here, recurrent arteries here, palmar arches here. Anastomosing systems to make sure there are safety nets to connect blood to all of these structures. Okay? Now, if I go back to the arch and I head down toward the diaphragm, the thoracic aorta here, so the aortic arch turns at the heart and it heads downward, behind the heart, on the posterior side of the heart. And as it does, it gives off major branches to structures in the thorax, all named for what they supply. You don't have to memorize this. To the heart, to the lungs, to the esophagus, to the chest, to the diaphragm. All vessels named for structures that they supply through the thorax. Major branch points of the thoracic aorta, supplying the major structures that are in the thoracic body cavity. Now, when you cross through the diaphragm, this is where you're going next week, right? Everybody finish the top? And some of you are working on the bottom. As you pass through the diaphragm, you begin to pick up the branches on the bottom. Okay? So let's start at the top here. Those little fibers right there are intended to illustrate the diaphragm. So we know this, that there are vessels on the top of the diaphragm, and we know that there are vessels on the bottom of the diaphragm to supply this extremely important muscle, the superior and inferior pharynx. So what would I call the red lines that I see on the superior aspect of the diaphragm? In the dissection, if I label the red lines that you see on the superior aspect of the diaphragm, those are superior pharynx. The red ones on the inferior aspect are the inferior pharynx. Blood supply on both sides of this skeletal muscle. Then, as I continue down this aorta, I'm going to give rise to what are some very large blood vessels. Huge blood vessels. At this point, most of the vessels that we have learned, with the brachiocephalic being the exception and the anterior communicating artery being an exception, all the ones that we've been learning have one that goes on the right and one that goes on the left. So all these things we've been talking about have rights and lefts. On the abdominal aorta, there are 3 blood vessels that essentially are responsible for everything in the abdomen. And they are not paired. There's one each. And here are their names. The first one is the celiac. The second one is the superior mesenteric. And the third one is the inferior mesenteric. These are the 3 unpaired vessels of the abdominal aorta that supply blood to the abdominal structures. The celiac, the superior mesenteric, and the inferior mesenteric. Now, for those of you who were listening to me earlier in this class, when we learned the anatomy of the sympathetic nervous system, you heard this before. What I taught you was this. I said, in the sympathetic nervous system, preganglionic projections go to the chain. Postganglionic projections go from there to the structures. But there are some exceptions to that rule. And the biggest exceptions, I should say, some of the major exceptions, because that goes, you can go in different directions with this. Some of the major exceptions of the sympathetic anatomy are fibers that come from the spinal cord that do not synapse in the chain. They pass through the chain, and they go to what are called peripheral sympathetic ganglia. Those ganglia are located at the trunks of the major unpaired vessels of the abdominal aorta. And we call them the celiac ganglia, the superior mesenteric ganglia, and the inferior mesenteric ganglia. These are the locations where these vessels are coming off, are the locations of major sympathetic ganglion cells. They're located here. And so here they are again, this time blood vessels. 3 major unpaired vessels supplying the structures of the abdomen. Now, the first one, the celiac trunk, this first major vessel, is going to give rise to major vessels that supply three major organs. They are the hepatic, the left gastric, and the splenic. Those all have to be found. In fact, some of you did this already. Who did this already? I showed you guys, right? The left gastric to the stomach, the splenic to the spleen, and the hepatic to the liver. Now, I'm not going to walk you through the sequence here, but in the lab you're going to have to do this. The hepatic artery actually, if you got in on board your little blood vessel rocket ship and rode it out there, you could ride the hepatic now toward the liver. And as you get to the liver, you could turn in the liver. The blood vessel in the lab you'll find, the gastroduodenal artery. You turn in that gastroduodenal artery, you make your way over toward the pancreas and the duodenum, where you would enter into the anterior pancreaticoduodenal. You keep driving down the posterior pancreaticoduodenal, and you can come out on the other side in the superior mesenteric. There is an anastomosing system from the celiac trunk to the superior mesenteric artery, protecting all of those organs. So the first two huge vessels that are unpaired that come off of this thing are actually connected to each other through an anastomosing system. And you have to find those in your cat. Okay, so that's the celiac. The next major branch, right about where the superior mesenteric comes off, are the renal arteries. Those are easy, huge. Some estimates suggest that the renal arteries contain almost 1/3 of all of the blood passing down the abdominal aorta. So we're talking about 33% of all the blood that passes here goes into these renal arteries. What does that tell you about this gland? Oh my word, right? This has got to be an important spot. These vessels are huge. And so the amount of blood flow to the kidneys is enormous. Now, where these renals come off, if you follow the renal out, you can see that there's a tiny little branch. These are exactly like this in the cat. A tiny little branch that comes off here that goes to the adrenal gland. And we call that branch the inferior suprarenal artery. Now I waited to bring it up here so that I can work my way backwards with this. This suprarenal artery, coming off the renal, has a buddy that comes off of the abdominal aorta called the middle. And it has another buddy that comes off of the inferior phrenic. You can see the inferior phrenic here passing up to the there's labeled right there. I see, man, it's labeled in the aorta. That's not right. The inferior phrenic here passing up to the diaphragm. You can see another one coming off of it. So there's one vessel coming off of the renal, one coming off of the aorta, and another one coming off the inferior phrenic artery, all going to one tiny gland, the adrenal gland. There are 3 suprarenal arteries. I wonder if this gland is going to be important. You see what I'm saying? 3 vessels, 3 different origin points to go to the same gland. It must be important. Now the superior mesenteric comes off next, and the superior mesenteric is responsible, this is a very important observation to make here, the superior mesenteric is responsible, as this picture shows you, for supplying most of the organs of digestion, specifically the intestines. It is responsible for supplying all 3 regions of the small intestine, which are not really illustrated here. This just shows you the end of it. So the small intestine is split up into 3 regions. The duodenum, or the duodenum, depending on who you're asking, the jejunum, and the ileum, 3 major sections of small intestine. They are all supplied by the superior mesenteric artery. The small intestine is the longest and most significant to the digestive system. Most of the important things that happen in digestion happen here in the small intestine. So the superior mesenteric then is a critical, it is the digestion blood vessel, the superior mesenteric artery. Now, its influence continues, as you can see here, in these branch points. It continues into the large intestine. So where the small meets the large, so there's your ileocolic or ileocecal vessel. There's your appendix coming off right there. There's the cecum of the large intestine. And then this would be the this would be the ascending portion of the large intestine. This across here would be the transverse, and there's the descending. Now, the superior mesenteric is responsible for supplying this ascending colon. It is the major supplier of the entire small intestine, the ascending portion of the large intestine, and you see how this diagram cuts this thing? It is responsible for supplying some of the transverse colon. Now at this point where this cut has been made right here, there's a major anatomy change. At this cut, a little past halfway in the transverse colon, the inferior mesenteric becomes the primary responsible vessel for feeding blood. So there is a regional issue going on here related to the development of the intestine, where the superior mesenteric gets most of the intestine all the way to the transverse colon. And from the transverse colon down, you get inferior mesenteric. The reason I point that out is because we see the exact same thing happen here in the influence of the nervous system. If I ask you what nerve runs digestion, you should say vagus, cranial nerve 10. If I asked you what part of the nervous system the vagus is in, you would say parasympathetic. But you would also tell me that there is parasympathetic information coming out of the sacral divisions of the spinal cord. And you'd be right. So in the nervous system, the same thing happens here. Responsibility is passed on. This is where the vagal influence in digestion runs out. Where the transverse colon is cut right here, the superior mesenteric says, your job, inferior mesenteric, you got the rest of this. At the same location, the vagus says, I'm done here, your job. And the rest of this in the digestive system is controlled by the sacral divisions of the spinal cord. So this picture is important in the way it divides the transverse colon here. I will finish the arteries and the veins on Monday. And then we will do heart on Monday.